Hello everyone. Okay, so in this video we are looking at touching circles. So what do we mean by touching circles? Well, circles can touch two ways. They can touch externally and they could touch internally. So what it means when two circles are touching, it just means they are just kind of intersecting at one point. So when we say circles touch externally, it looks like this. If we say circles touch internally, it looks like this. So it's kind of inside the circle here. It's two very easy ways to prove if a circle touches internally or externally. First off, we have externally. The distance between the two centers equals to the sum of the two radiuses. So if the two radiuses add together to get the distance between the two centers, then they touch externally. If the distance between the two center points here equals the radiuses minus each other, then they touch internally. So let's have a look here. Show that the circles x squared y squared minus 2x minus 4y minus 4 equals 0 and x squared minus 8x minus 12y plus 48 equals 0 touch externally. So externally, the distance between the centers is equal to the sum of the two radiuses. So let's find my center points here. So I'm going to call this C1 and this C2. So the center of C1 is going to be equal to, so G, so 2G equals minus 2. G is equal to minus 1. 2F is equal to minus 4. F is equal to minus 2. And then C is equal to minus 4. So my center is minus G minus F, which is 1, 2. And then my radius is equal to the square root of G squared plus F squared minus C, if you recall. So it's going to be minus 1 squared plus minus 2 squared plus 4, because it's minus negative 4. That is going to be 1 plus 4, which is going to be 9, which is equal to 3. So there's my radius and then my center point. For the second circle, C2, so I have 2G is equal to minus 8, G is equal to minus 4. 2F is equal to minus 12, F is equal to minus 6. So I have 4, 6 as my center point, and my radius is going to be minus 4 squared plus minus 6 squared minus 48, which is going to be equal to 16 plus 36 minus 48. Which is going to be the square root of 4, which is equal to 2. So here's my two center points, and then there are my two radiuses. So let's check my distance now. So my distance between these 2 points. So that's going to use my distance formula. So 6, so 6. So 4 minus 1 squared plus 6 minus 2 squared, which is equal to 3 squared plus 4 squared, which is equal to root 25, which is equal to 5. So my distance is equal to 5. Let's check. D is equal to or1 plus or2. 5 is equal to 3 plus 2. 5 is equal to 5. Therefore, they touch externally. Right? So let's look at the second example now. Now, they touch internally. So we want to prove that these two circles touch internally. So remember, D is equal to or1 minus or2. So the two radiuses subtract each other. Usually what we do is we always kind of take the bigger radius and subtract it from the smaller radius. So C1, my center point is, so G is going to be 2, so it's going to be minus 2 is my x coordinate. Minus 6 divided by 2 is minus 3, so that means my y coordinate is going to be positive 3. And then my radius is going to be equal to 2 squared plus minus 3 squared plus 12, because minus c. So minus c is minus negative 12. That's going to be 4 plus 9 plus 12, which is root 25, which is equal to 5. And then circle C2. Well, G is going to be equal to 0 because I have no x coefficient, so 0. And then minus 3y, so F is going to be equal to minus 3 over 2. So it's going to be 3 over 2 is my x coordinate. My radius then is equal to 0 squared plus minus 3 over 2 squared minus negative 4, so it'll be plus 4. So 3 over 2 plus 4, which is going to be equal to the square root of 25 over 4, which is equal to 5 over 2. So there's my two radiuses and my two center points. Let's calculate my distance. My distance between the 2 points now. So I'm going to have minus 2 minus 0 squared plus 3 minus 3 over 2 squared. That is going to be minus 2 squared plus minus, just plus 3 over 2 squared. It's going to be 4 plus 4 plus, so my distance is going to be equal to root 25 over 4, which is 5 over 2. So my distance equal to 5 over 2. I'll sub it in. So my distance should equal to or 1 minus or 2. So 5 over 2 is equal to 5 minus 5 over 2. 5 over 2 is equal to 5 over 2. Therefore, they touch internally. So now these two circles touch internally. They look like this. Right, so let's look at some exam questions now. So, this is from 2021, so this is a very recent question. Show that the circles C and S touch externally. So remember, D is equal to, so externally, or 1 plus or 2. So my center point of circle C is going to be, so G is going to be equal to 2, F is going to be equal to minus 1. So my point is minus 2, 1. And my radius is going to be equal to 2 squared plus minus 1 squared minus C, which is plus 95, which is equal to root 100, which is equal to 10. Then this circle here, this is actually way easier. So my center is going to be 7, 13, and my radius is going to be root 25, which is equal to 5. So that's so there's my radius, or 2. My center point, let's calculate my distance. My distance between the two center points is going to be equal to minus 2 minus 7 squared plus 1 minus 13 squared. That is going to be equal to minus 9 squared plus minus 12 squared. That is equal to 81, this is 12 here, 81, 144, 81 plus 144, root 225, which is equal to 15, right? And D is equal to or 1 plus or 2. Let's test it out. 15 equals 10 plus 5. 15 equals 15. Therefore, they do touch externally. Right. Let's look at this question here. The circles x squared plus y squared minus 4x minus 6y plus 5 equals 0, and x squared plus y squared minus 6x minus 8y plus 23 equals 0 are two circles. Prove that they touch internally. So D is equal to or 1 minus or 2. So just to kind of speed up the process a little bit, the center point for, I'm going to call the circle C, I'm going to call this circle F, S. Circle C, the center point is going to be equal to, so G is going to be equal to minus 2, so it's going to be 2. Minus 3 divided by 2 is minus 6 divided by 2 is minus 3, and then minus F is 2, 3. My radius then is equal to, so minus 2 squared plus minus 3 squared minus 5. 4 plus 9 minus 5 is going to be root 8, which is 2 root 2. That's my first one. My second one, my center point is going to be, so G here is going to be equal to -3. F is going to be equal to -4. So remember, always 2G is equal to -6. So we've got G is equal to 3. So my center point is 3, 4. My radius then is equal to -3 squared plus -4 squared minus 23. 9 plus 16 minus 23 is equal to √2. So let's test it out now. My distance between the 2 points, the 2 centers, is going to be 2 minus 3 squared plus 3 minus 4 squared. Put that in your calculator, you're going to get √2. And therefore, D is equal to 2√2 minus √2. √2 is equal to √2. Therefore, they touch internally. I have proven that they touch internally. Right. Part II of this question from 2007 is find the coordinates of the point of contact of the 2 circles. We want to find the point of contact or the point of intersection, right? So we did this in the last video, but to revise it again, right, what I need to do is I need to subtract my 2 equations of the circle to get my common chord, and I need to find where they intersect with the circle. Now, we know that they touch, these circles touch, so they're going to have 1 point of intersection, so hopefully it makes the question a little bit easier for us. So let's subtract now. So x squared plus y squared minus 4x minus 6y plus 5 minus x squared plus y squared minus 6x minus 8y plus 23. X squared minus x squared, y squared minus y squared, minus 4x minus negative 6x. That's going to be minus 4x plus 6x, which is 2x. Minus 6x minus negative 8x, so it'll be minus 6x plus 8x, which is plus 2y. Then 5 minus 23, which is equal to minus 18. And I notice I can divide across here by 2. So x plus y minus 9 equals 0. So that is my equation of my common tangent. Get x or y on its own. It doesn't really matter. I'm just going to get x on its own. Actually, I'll get y on its own. Why not? So I'll get y on its own. Y is equal to, so bring everything over to the left-hand side, 9 minus x. So sub this in to one of my circles. I'm just going to sub it into circle C. So we have x squared plus 9 minus x squared minus 4x minus 6y plus 5 equals 0. So I have here x squared plus 81 minus 18x plus x squared minus 6x. Oh my god, I forgot to sub in the y here. My bad. So minus 6 times 9 minus x plus 5 equals 0. Minus 6 times 9 is minus 7. Nope. Minus 54. Plus 6x plus 5 equals 0. So I am going to be left with, so x squared 81 minus 18 plus x squared. This is minus 4x, I do apologize. Okay. So x squareds, gather them up. I have 2x squareds. Minus 18 minus 4x plus 6, which is going to be equal to minus 16x, and then 81 minus 54 plus 5 is 36 equals 0. Divide across by 2, I have x squared minus 8x plus 16. Two numbers that multiply to get 16, but add to get minus 8 is minus 4 minus 4. So x is equal to positive 4. We only have 1 point here. And then sub in to find y. So then to find y, I'm going to have y is equal to 9 minus 4, y is equal to 5. So my point of intersection is 4, 5. How fun was that? Right. Let's look at another one here. This is the equation of a circle. Write down the coordinates of a center and length of radius. I'm just going to call this circle C. So the center of this circle is going to be the center of the circle is going to be 3 minus 2, and its radius is going to be equal to, so G is equal to minus 3, F is equal to 2, C is equal to minus 12. That is going to be minus 3 squared plus 2 squared plus 12. Remember, it's minus negative 12. 9 plus 4 plus 12. The radius is equal to, I think, 25. Sub it in, you get 5. And the second one here, this is another circle where k is a real number. The two circles touch externally. So saying the two circles do touch externally, find the value of k. So I'm going to call this circle S. So circle S, the center of this circle is going to be minus 6, 10. And my radius, I don't know what my radius is. I'm just going to call it or2. But I do know they touch externally. So D does equal to or1 plus or2. So what we're going to end up doing here is we're going to solve for the radius now of this circle here. And then when we do that, we can then work backwards and solve for k. So what's the distance between these two points? So distance is equal to the square root of minus 6 minus 3 squared plus 10 minus negative 2, so it'll be plus 2 squared. That is going to be equal to 15. The 15. So 15 is equal to 5 plus or2. Or2 is equal to 10. So I have my second radius is equal to 10. So or2 is equal to 10, which is equal to the square root of, so G, F, and C. So G in this case is going to be half of 12, which is 6. And F is half of minus 20, which is minus 10. So 6 squared plus minus 10 squared, then minus k. So I'm going to have 10 is equal to 36 plus 100, so it'll be 136 minus k. Square both sides, I get 100 equals 136 minus k. K is going to equal to 36. That is the value of k. How fun. That was from the year 2000. Right, this one now from 2012. Write down the center and radius length of each circle. Prove the circles are touching. Verify that 4, 7 is a point they have in common. Find the equation of the common tangent. Right, so write down the center and radius length of each circle. So the center of this circle, so G is minus 3, F is minus 5, C is 29. So the center point is going to be 3, 5. And the radius, or 1, is going to be equal to, so minus 3 squared plus minus 5 squared minus 29. And put that in the calculator. You get 9 plus 25 minus 29, which is root 5. Then the second one here, G is equal to minus 1, F is equal to minus 1. So my center point is 1, 1. Then my radius is equal to minus 1 squared plus minus 1 squared minus 43. So I become a plus 43, which is equal to root 45, which is 3 root 5. So prove that the circles are touching. So if it doesn't say touching internally or externally, it just says it proves it's touching. So D is equal to or1 plus or2, or D is equal to or1 minus or2. So one of them will hold. So I have my two radiuses here. my distance between the two center points, so these are my two center points up here, so it's going to be 3 minus 1 squared plus 5 minus 1 squared, which is equal to 2 squared plus 4 squared, which is equal to root 20, which is 2 root 5. And D is equal to, if you look at it here, it's going to equal to or 2 minus or 1. So 2 root 5 is equal to 3 root 5 minus root 5. 2 root 5 is equal to 2 root 5. So they are touching internally. They are touching internally. Verify if 4, 7 is a point they have in common. So we just need to sub the point 4, 7 into each of these. So 4, 7. So I have 4 squared plus 7 squared minus 6 times 4 minus 10 times 7 plus 29. And if you put all equals 0, and if you put all in your calculator, you will get 0 is equal to 0. And then same for the second circle. 4, 7, sub it in. 4 squared plus 7 squared minus 2 times 4 minus 2 times 7 minus 43 equals 0. If you put it in your calculator, you will get 0 is equal to 0, verifying our answer. Then finally, last one here, find the equation of the common tangent. Well, that's very easy. I have both of them into general form, so I just need to subtract them. So C1 minus C2. So x squared plus y squared minus 6x minus 10y plus 29 minus x squared plus y squared minus 2x minus 2y minus 43 equals 0. So x squared minus x squared, y squared minus y squared minus 6x minus negative 2x. So that's going to be minus 6x plus 2x, which is minus 4x. Then minus 10y minus negative 2y. That's going to be minus 10y plus 2y, which is minus 8y. And then 29 minus negative 43, which is 29 plus 43, which is equal to 72. And I notice here I can divide across by 4. So I'm going to divide across by minus 4. So it's going to be x plus 2y minus 18 equals 0. That is the equation of the common tangent there. Right, finally, last question here. Does two circles S and C touch internally at B as shown? Right, the equation of circle S, so the S is the bigger circle here, is x minus 1 squared plus y plus 6 squared equals 360. What is the center? Well, the center is 1 minus 6. And the radius is root 360, which is equal to 6 root 10. Right, the point K is the center of circle C. The radius of C is 1/3 the radius of S. The coordinates of B are 7, 12. Find the coordinates of K. So I know that the radius of C is 1/3 the radius of S. So here is going to be 1/3 of the entire thing here. So what's happening? Point K is splitting the line B from the center, 1 minus 6. It's splitting that in the ratio 1 is to 2, or 2 is to 1. Right? This is 1/3, and then this represents 2/3 then of the entire radius. So there's two ways we can do it. We can do translation, or we can do our ratio, our point splitting a line into a given ratio. So there was two ways of doing it. Right, I'm just going to do splitting into certain ratio. So B is equal to 7, 12. So let's see what happens here. So bx1 plus ax2 all over b plus a, and by1 plus ay2 all over b plus a, and a is to b, which is going to be 2 is to 1. So splitting it into ratio 2 is to 1. So that is going to be 1 times 1 plus 2 times 7 all over 3. And then my y coordinate is going to be 1 times minus 6 plus 2 times 12 all over 3. If you put that in your calculator, that's going to simplify down to 15 over 3, which is 5. And then 24 minus 6 is 18. 18 divided by 3 is 6. So the point is 5, 6. So point K, or the center of circle C, is 5, 6. 5, 6. So find the equation of C. Well, I can use the simpler one, so x minus h squared plus y minus k squared is equal to r squared. I have my center, 5, 6, so this is h, this is k, and my radius is 1/3 of this radius, so it's going to be 2 root 10. So that is going to be x minus 5 squared plus y minus 6 squared is equal to 2 root 10 squared. So x minus 5 squared plus y minus 6 squared is equal to 40. And that is the equation of C. And then finally, last part here is asking us to find the equation of the common tangent, right? Well, we're asked to find the equation of the common tangent. So we know there's a common tangent here, and the common tangent is happening at B, right? So I am looking for the equation of this line right. Ooh, this line right here. So what I need to do first is I need to find the equation of this slope. That's fine. That's a fine equation. I need to find this slope here. So I know B is 7, 12. And then this center is 1 minus 6. So what's my slope here? My slope is going to be equal to minus 6 minus 12 all over 1 minus 7, which is going to be minus 18 all over minus 6, which is equal to positive 3. So my slope of my perpendicular line is minus 1/3. So now I have my slope and I have my point. So my point is 7, 12 and my slope is minus 1/3. And my point is 7, 12. So y minus 12 is equal to minus 1/3 times x minus 7, multiplied across by 3. 3y minus 36 is equal to minus 1 times x minus 7. 3y minus 36 is equal to minus x plus 7. And then I'm going to get x plus 3y, then minus 36, and then bring 7 over, that'd be minus 7, be minus 43 is equal to 0. And that's the equation of the common tangent there. Right, so that is touching circles and all the exam questions. I hope this video was some help to you guys, and I'll catch you guys later. Bye.